All right, welcome to class, everybody. Just a reminder that the test will close today. So if you haven't taken the test yet, make sure you make time to go do that in the testing center. And our lesson for today is section 8.2, which is about the quadratic formula. So in our last lesson, we talked about how to complete the square. So just as a review, what would our first step be if we wanted to complete the square for this equation? Perfect. Yep. We divide by 7 because the x squared term has to be by itself. So we'd get x squared minus 16 over 7x plus 100 over 7. And this would equal 0. What would my next step be? Say it again. Perfect. Yep. So we'd move our constant to the other side. And that would give us negative 100 over 7 on the right-hand side. And then from here, we want to ultimately factor the left-hand side into a perfect square. So when we look at this side, right, or this term right here, what is the number going to be in our perfect square? Perfect. Yep. So we'd have negative 16 over 14 because you always take half of what that number is. And you could reduce this if you wanted to, but it actually turns out that it usually no, let's go ahead and reduce it. So if we reduce 16 over 14, that would be 8 sevenths, right? Because they can both be divided by 2. So we get negative 8 sevenths. However, this polynomial does not factor to negative or x minus 8 sevenths squared, because you would also need to have a 64 over 49, because this negative 8 sevenths times itself will equal positive 64 over 49. Is everybody good? This is kind of a quick review of what we did last class. So if I add it to that side, I have to also add it to the other side. And that gives me that answer. And then if I simplify that right-hand side, negative 100 over 7 could be rewritten as negative, let me do this in blue, negative 700 over 49, because you can multiply the top and bottom by 7. And negative 700 plus 64 would give you 600 and what? 36. And that would be a negative over 49. And then you'd like square root both sides and solve it from there. So that's what we did last class, with learning how to complete the square. So I want to take a look at what would happen if we completed the square for a generalized equation. So you guys won't have to do this on your homework, but this is very relevant to what we're moving into. So in this generalized equation, A could be any number, could be a fraction, could be whatever, like positive, negative, can be any number. Then B can also be any number, and same thing with C. So if I was going to complete the square for this equation, I would start off by subtracting C from both sides. So I'd have AX squared plus BX equals negative C. Then I would say, okay, well, now I need to get the x squared so it doesn't have an a with it. So I divide both sides by a, which would give me whatever b is divided by a times x equals negative c divided by a. Is everybody good with that so far? And again, you don't have to do this on your homework. This is just one example I'm going to do in class. Okay, so then I would factor, or I would make this a perfect square. And I want my number inside of my perfect square to be half of this number. Well, I don't know what b is or what a is, but I know that half of whatever that number is, when you divide them, is going to be b over 2a. Does that make sense? Why? Because like you multiply by a half. Okay, so, and it would be a positive in this case because I had a plus b over 2a. And then if I square that number, I'm going to get b squared over 4a squared. And that's the number that I would add to both sides. Everybody good with this so far? Okay, now on this right-hand side, I have two fractions, but I can't add them together unless I have common denominators. So I'm going to make common denominators by multiplying the top and the bottom by 4, and I'm going to multiply by an a on the top and on the bottom. So the bottom will become a squared, the top one will become 4ac or 4ca. Any questions about that? Okay, so the right-hand side simplifies, and I'm going to write the b squared first because it's positive. So I get b squared minus 4 times a times c all over 4a squared. Then if I wanted to solve this equation, my next step would be to take the square root of both sides, and I would get x plus b over 2a equals either plus or minus the square root of b squared minus 4ac, and the square root of the bottom is 2a. Any questions about that? Okay, then the next step would be just get x by itself by subtracting b over 2a from both sides. And this gives me negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then you could combine those two fractions together because they both have common denominators. And you end up with the solution that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So how many of you guys recognize that? Yeah, that's the quadratic equation. So the quadratic equation is literally just a generalized version of completing the square, which means that for any equation where you would use completing the square to solve it, you can also just use the quadratic equation. And in order to use the quadratic equation, you need to have your equation set up like this to start with. So the setup of the quadratic equation assumes that your equation has everything on one side of the equation equal to 0. And then whatever's with the x squared is your a, whatever's with your x would be b, and whatever's with your c, or whatever's by itself would be your c. Does that kind of make sense? So essentially we have 3 different methods that you can use to solve quadratic equations. You can do factoring, where you set your equation equal to 0, you factor it, and then you see what makes each factor equal 0. I personally like that method the most. That's my favorite, but it doesn't always work because sometimes it's not factorable. So factoring was the first method we learned. Then there's completing the square, which will always work regardless of what your equation is. And there's also the quadratic equation, which is essentially the same thing as completing the square, but you're basically just like plugging numbers into the equation that's already been solved. Does that make sense? So if you like formulas, you can just always stick with the quadratic equation and you don't have to complete the square because they're basically doing the same thing. If figuring out how to simplify that formula is really confusing for you, but you felt really good about completing the square in the last lesson, you can just always complete the square and you don't ever have to use the quadratic formula. So you can kind of choose whichever method you like the most. So in this lesson, I'm going to go through and use the quadratic formula so that you guys can kind of see how it works. But on your homework, you guys can choose to do whichever method makes the most sense to you. So let's go through an example with the quadratic formula. So I'm going to rewrite out the quadratic formula really quick. So our solution will be negative b plus or minus the square root of b squared minus 4ac all over 2a. So in order to use that formula, I have to first of all make sure that my equation is in the correct form to be able to use it. And that form is that everything is on one side of the equation and it equals 0. So when I look at my equation, is my equation in that form or do I need to do something different? Yep, it's good because it all equals 0. And in this case, what is a going to equal? Yep, 1, because 1 is the coefficient that goes with the x squared. What is b going to equal? Yep, negative 8. And what is c going to be? Perfect. So I can say, okay, my solutions are going to be x equals negative b. So since my b was -8, what's negative -8? +8. So I'm going to have +8 plus or minus the square root of b squared. Now b was -8. What is b squared? 64. Is it going to be positive or negative 64? Positive, because you're squaring b and the negative is included in b. So -8 times -8 will give you a +64. Then I have -4 times a times c. So -4 times a is just going to be -4 because a was 1. -4 times c will give me -48. And then this will all be divided by 2 times a, and a is 1, so that's just going to be 2. Everybody good with how you plug it in? So when you plug things in, always make sure you're really aware of your negatives, because negatives are one of the things where it's easiest to get off track. So make sure you pay attention to those. So now we can just simplify this. We get 8 plus or minus, and then 64 minus 48 is going to be, oh, great. It's a perfect square. So we get the square root of 16 all over 2. And since it's a perfect square, that actually means that you can simplify this out into both solutions, because you can say this is going to equal, I'll either have x equals 8 plus 4 over 2, or x equals 8 minus 4 over 2. So 8 plus 4 over 2 is going to be 12 divided by 2, which is 6. So that's one of my solutions. And the other one is 4 over 2, which is 2. So those two numbers will be the solutions to this equation. And this one actually is one where you could have done factoring, which probably would have been way easier. Because if you factor this equation, I'm just kind of doing this in my head really quick. But if you factor it, 12, let's see, what that'd be, 6 and 2. And the 2, yeah, they both be negative, yep. And if those equal 0, oh, I guess since we already knew the answer, I could have just factored it that way. But you can see that that factoring does give us those two answers. So you can solve them by factoring, or you can solve them with the quadratic equation. But the quadratic equation and completing the square are basically the same process. One of them is just stuck in a formula. One of them is a process that you calculate. All right, any questions on that? Okay, so one thing to know is that this square root part of the equation can give you imaginary numbers, because in this case, we got a positive 16, which just simplified 4. But sometimes you might get like the square root of negative something, in which case you'll have an imaginary number and you won't be able to simplify it down to something like this. It will stay more in that form right there. So let's do another example. Let's do this one. So in this one, we have 20x squared minus 70x equals 0. And if we want to use the quadratic equation, we always need to make sure that our equation is set up where it equals 0. Is that the case in this equation? Yep. So that means I can use my quadratic equation. I'll get negative b plus or minus square root of b squared minus 4ac all over 2a. And in this equation, what is a going to be? 20. And what is b going to be? And what is c going to be? Perfect. Okay. So my solution is going to be x equals negative 70, which is positive 70. Then plus or minus the square root of b squared. So negative 70 squared, I think, is going to be 4,900, because 7 times 7 is 49 with 2 zeros after it. And then I have negative 4 times a times c. So negative 4 times a is negative 80. But when I multiply by c, I just get 0. So this is going to be minus 0 all over 2 times a, which is 40. So when I simplify this, the square root of 4,900 is 70. And so I get 70 plus or minus this 70 divided by 40. And so you could simplify this by doing 70 plus 70 and divide by 40, or you can do 70 minus 70 and divide by 40. But even if like this had an imaginary number in it, so I don't know how I could actually change the equation, but like, let's say this was 70i instead of just 70. You could still simplify this because the top can have a 10 factored out of it, and you get 7 plus or minus 7 over 10 times 4, and the 10s will cancel. So even if you have imaginary, like in this case, we didn't have imaginary numbers, so you could simplify it kind of like the one we just did. But even if it does have imaginary numbers, you still want to see if there's common factors between the top and the bottom that will simplify the fraction. Any questions about that? Okay. So if we had an equation like this one, how do you guys think we would start solving it? Perfect. Okay, because we have to have it equal to 0. So we'll have x squared over 3 minus 3x over 2 plus 2 equals 0. And then what would you do? Yeah. So, I mean, you could, if you wanted to, you could plug in a equals 1/3 and b equals -3/2 and c equals 2. But it'd be way easier if there weren't any fractions that you were plugging in. And so if you multiply both sides by 6, then that gives you 2x squared minus 9x plus 12 equals 0. And that's going to be way easier to plug into your quadratic equation. Do you guys want me to plug it in, or are you guys good if essentially like you just plug it into the formula? And I can go through that if that's helpful, or if you guys feel like you've got the formula down. My main point was I just wanted to show you guys that you can multiply both sides by something to get rid of fractions if it makes it easier. So can you guys give me a thumbs up if you're good to move on? Thumbs down if you would like me to go through another example of plugging it in. Okay, and I will go through a few more examples, but I just want to make sure we look at all the different types. So let's maybe do this one. So in this one, what do you guys think we would do to solve this equation? Okay, so we could find common denominators. If we found common denominators, though, we'd still have fractions, you know, like once we combined everything. Is there a way that maybe we could get rid of the fractions altogether? Oh, yes, sorry, did I maybe missed the first part of what you said? Sorry about that. Okay, perfect. Yeah, so if we multiply by the number that would be the common denominator, that will cancel them all out. So I can multiply by a 5, multiply by an x, and multiply by an x plus 8. So I'll do that on both sides. Because remember, an x plus 8 is a different type of factor than x is. So you have to multiply by both of them. So on the right-hand side, when I do 5x times x plus 8 divided by x plus 8, the x plus 8s cancel out and I get 5x. On the next one, if I do 5x times x plus 8 divided by x, the x's will cancel out. And then I also am multiplying by a -1, so I'll get -5 times x plus 8. Is everybody good with how I did that? And then on the right-hand side, the 5s are going to cancel out, which gives me x times x plus 8. Okay, so that looks a lot simpler than what I started with, but it's still kind of complicated. What would we do next? Yep, if we distribute, that'll give me -5x minus 40. And I can also distribute the x, which gives me x squared plus 8x. And then what would we do next? Say it again. Yep, so if we combine like terms, these two will cancel out to 0x because 5x is minus 5x, will be 0. Perfect. Yep. So we can also add 40 to both sides, which would give me 0 equals x squared plus 8x plus 40. And now that we have it in this form, what would we do now? Yep. So now we can plug it into our quadratic equation, which says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that would give us the solution x equals, oh, actually, I should say, what's a going to be in our equation? And what is b going to be? And what is c? 40. So I would plug these in and I'd say, okay, well, negative b is going to be the opposite of positive 8, which is negative 8. Then plus or minus the square root of b squared, which is 64. Then negative 4 times a is negative 4. Then times 40 is going to be negative 160. And this is all over 2 times a, which is just 1. So 2 times 1 is 2. Then I can say, okay, well, what's 64 minus 160? Is it 90 or negative 96, I think?
Yes.
Okay, so we get negative 8 plus or minus the square root of negative 96 all over 2. Now I need to simplify the square root of negative 96 to see if I can reduce my answer. So I'll do this up here. If I factor out 96, I know that 9 and 6 are both divisible by 3. So I'd get 3 times 32. 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4, which is 2 times 2. So the square root of negative 96 is going to equal the square root of negative 1 times 5 2s times a 3. And the square root of something squared is just itself. So the square root of 2 squared, I'll zoom in a little bit, is going to be 2. Then the square root of this 2 squared is going to be another 2. And the square root of negative 1 is going to be I. And then the square root of 2 times 3, you can't simplify. So you'd have the square root of 6. And this is going to be 4i square root of 6. Is everybody good with that? Okay, so then we can simplify this further because this is going to be negative 8 plus or minus this 4i square root of 6. And when we look at all of the terms here, so we have 2 terms in the top and 1 term in the bottom. Is there anything we could factor out of the top that could cancel out something on the bottom? Yeah, they're both 8 and 4 are even numbers. So maybe I'll write this over here. So we could write this as 2 times negative 4 plus or minus 2i square root of 6 all over 2. And then the 2's would cancel and this would be your final answer. So this is an example of what I was talking about earlier, where you always want to check and see if you can cancel things out of the top and the bottom. But it has to be in factored form to be able to cancel it out. Like you couldn't, like if this was like a 3i instead of a 4i, you couldn't just say like, oh, negative 8 divided by 2 is negative 4 and leave it like that, because these are 2 separate terms and you can only cancel things out in fractions if they're in factored form. So that's how you would do a problem where you have imaginary numbers. Any questions on that? Okay, so let me ask you guys this. So like when we looked at the original expression, like this one, do you guys feel relatively comfortable on knowing like, oh, I need to get rid of the fractions, like knowing that that should be your first step? Is that okay? Cool, because that was kind of the main focus of this problem. And I'm glad that that's feeling natural for you guys. Okay, so the last one well, actually I have 2 more problems I want to go over. So the last one with the quadratic formula though, is this one. So on this one, what do you guys think we should do first if we want to solve it? Any ideas? Okay. So if we FOIL, because well, let's actually look at the structure of this first. So that's a great start, because essentially we have this stuff plus this stuff equals this. But our quadratic formula only works if you have like no parentheses, right? So we would want to FOIL that out to get rid of the parentheses. So y times y will give us y squared. Y times 6 will give us 6y. 4 times y will give us 4y. And 4 times 6 will give us 24. And then what about the y plus 1 squared? Do we want to keep that the same, or how do we want to work with that? Yep, so we could write this as y plus 1 times y plus 1, and then we could FOIL that out as well, right? So I'll just kind of do that in this step as well. So I have y squared plus 1y plus 1y plus 1, and that's being added to the other stuff I FOILed. Then what would I do next? Yep, combine the like terms. So my y squared terms could be combined, and that would give me 2y squareds. For my y terms, I have 1 plus 1 plus 6 plus 4. So I think that'd be 12 y squareds. And then my 1 plus my 24 is going to give me plus 25, and this equals 9. And then what would I do next? Oh, thank you. Thanks for catching that. Then what would we do next after that? Yep. Subtract the 9, because the quadratic equation, I mean, if you wanted to do the completing the square, you wouldn't necessarily have to do that. You'd actually probably subtract the 25 over. But assuming that you're going to use the quadratic formula, you want to have it equal 0. So we do plus 12y plus 16. That equals 0. And then you would take those numbers and plug them into the quadratic formula. Also, just like when we multiplied with the fractions, if you wanted to at this step, if you notice that they're all even numbers, you could divide the entire thing by 2, which would make your numbers a little smaller. So you could make this like y squared plus 6y plus 8 equals 0. But it would give you the same answer either way. You'd just be dealing with smaller numbers. So that's always a possibility. Are you guys good if I don't plug it in? Okay. All right. So the very last thing that you guys will see on your homework is they'll ask you to find fixed points of a function. So the definition of a fixed point is it's when the function equals the input of the function. So this notation right here is the output when you input an x into the function. And so essentially it's saying a fixed point is when the output equals the input. And the way that you solve it is you basically just set up an equation that looks like that. So if they gave you this function and they said the output when you input an x is x squared minus x minus 5. If they ask you to find the fixed point of that function, they're just asking you to find when does the output, which they told us is this, when does that equal the input? So you just say, well, this is when it equals x. And then how would we solve an equation like that? Divide by x. So if we divided by x, we'd get all that stuff equals 1. Yeah, you were on the right track. Instead of dividing, what would we do with the x? Subtract it? Yes. All right, so we get x squared minus 2x minus 5 equals 0. Is everybody good with why we would do that? And that's just to get it in the form. So you could do the quadratic equation, and then you would say in this equation, a equals 1, b equals negative 2, and c equals negative 5. And then you would plug those values into the negative b plus or minus the square root of b squared minus 4ac over 2a formula. And I think in this case, you would probably, I think you might end up with an imaginary number in that case. But that's how you find fixed points. So the only new information about fixed points is it's when the output and the input are equal to each other. So you just set up the equation like that. So I'll go back to this slide so you can write down the quadratic formula if you don't have that memorized. Is this something you guys would like me to put on the final? So you don't have to memorize it? Because I can do that if you need me to. Okay, awesome. I will put that on the final then. You guys can go ahead and get started on your homework. So guys, really quick, I want to go over question 9. I forgot to show an example of this. So question 9 has something sort of like this problem. This shouldn't be here, so sorry about that. So in this case, this is not a quadratic equation because this one has x cubes in it. And so if you have an equation that has a higher power than a quadratic equation, then you need to factor. So like in this case, we could factor this to be x times 2x squared plus 2x plus 7 equals 0, because you could factor out the common x term from each. Does that make sense? And then you use kind of like our factoring methods before, because this, like that's not easy to factor on its own. So I would use the quadratic equation to solve when 2x squared plus 2x plus 7 equals 0. So I'd apply the quadratic equation to that, because that's when that factor will equal 0. But then you'll also have the solution where this equals 0. And so that would be your other solution. And I think this one will give you an imaginary solution. This one will give you just the real solution 0. So sometimes you may have to factor it and then use the quadratic equation to solve one of your factors equal to 0. Does that kind of make sense on that? I think there might also be a question, I can't remember what number it is, but where you have to factor a sum of cubes as well. So like in this case, like if you had x cubed plus 8 equals 0, the way you would factor this is you look for what the two things are that you're cubing. So you would think about this as x cubed plus 2 cubed equals 0. And then you would factor that to x plus 2 times x squared minus 2x plus 4 equals 0. And is everybody good with that? That's just using the sum of cubes formula that you're welcome to look up if you don't have it written down. And then you would say, okay, well, this factor is going to equal 0 when x equals -2. And this factor is not factorable further. So you would use the quadratic equation to find out when x squared minus 2x plus 4 equals 0. So sorry that I forgot about that part.